Section 3 of 7.8, or Part 3 of 7.8, is talking about uniform motion. For uniform motion, we're going to make the assumption that motion is held at a constant rate. The formula for uniform motion is distance equals rate times time, which we're going to rewrite as time equals distance over rate. Also in uniform motion, we frequently deal with currents, whether it be wind or water. And when you are going upstream, the current is working against you. So the rate is the speed minus the current. When you are going downstream, the current is working with you. So the rate is speed plus current. So it says Barbara uses her canoe to travel on a river whose current is running at 1 mile per hour. After traveling 12 miles downstream, she turns around and makes the trip back upstream. She notices that she only covered 10 miles going upstream in the same amount of time that she covered 12 miles going downstream. So how fast would Barbara be paddling her canoe if the water was still? We're going to organize in a table. We're going to have upstream versus downstream. And our pieces that we need are distance, rate, and time. So when she was going downstream, she traveled 12 miles. When she was going upstream, she traveled 10. I know that the current is 1 mile an hour. So upstream, it's going to be her variable, we're going to use an R for rate, minus 1. And for downstream, it's going to be R plus 1. By our formula, the time is going to be the distance divided by the rate. So 10 over R minus 1 and 12 over R plus 1. And it says somewhere in here that the time is the same, in the same amount of time. So we're going to set our times equal. 10 over R minus 1 equals 12 over R plus 1. Cross multiply. So we have 10 times R plus 1 equals 12 times R minus 1. Distribute. And so we get 11 equals R. So Barbara's rate in still water would be 11 miles per hour. Next example, riding your bicycle. It is a 15-mile long path ending at a waterfall. Instead of upstream and downstream, we have uphill and downhill. So one weekend you notice that because the ride to the waterfall is partially uphill, your cycling speed returning is 2 miles an hour faster than the speed riding to the waterfall. If the round trip takes 8 hours, excluding the resting time, find the average speed cycling back from the waterfall. Let's summarize what we have. The distance, it is a 15-mile long path. The rate, we know that you go 2 miles an hour faster on the downhill trip. So by the formula, the time is going to be distance over rate, distance over rate. Now we don't get to set them equal this time. It says that the round trip takes 8 hours. So that means the going to the waterfall plus the return takes 8 hours. 15 over r plus 15 over r plus 2 equals 8. No cross multiplying here because we have this plus and 2 fractions. So we need the LCD. And when I multiply by the LCD, the r is going to cancel out. And then the r plus 2 is going to cancel out. And then nothing cancels out on the 8. Because I have a quadratic with a squared variable, I'm going to make it equal to 0. So that's 30r subtracted over and get minus 14r. Move the 30 over. Make life easier. Divide everything by 2. Factor. By trial and error, and I've already done this, so I know that it is 4r plus 5 and r minus 3. Set each factor equal to 0 and get answers of negative 5/4 and positive 3. But remember, we're talking about a rate, so the negative answer doesn't work. So our rate is 3, but remember what the rate variable was. The rate variable was the pace going to the waterfall. We want to know the speed coming back from the waterfall. To the waterfall is 3. Back from the waterfall is 2 miles an hour faster, we were told. So 5 miles per hour.